wide palette of content resources, complete collections of nearly all leading international publishers, a selection of scientific data collections, and then this was again a step on our way forward to set up a concept, an integrated concept of national knowledge infrastructure that we have started then from making this easy step of purchasing complete collections from leading publishers as say Springer, Elsevier, IEEE, and a few, well, whole list. You can, those of you who might be interested can find it on our webpage. And this was only a first step in our attempt to build a system that simultaneously provides access to international resources and provides an infrastructure for Polish publications to get available, accessible worldwide without any limitation. So from the very beginning, we were pursuing open access concepts to all resources that were not prevented from doing so. And this is what we have done in order to make the resources, Polish scientific achievements, better promoted worldwide. We have started actually from Polish mathematical school achievements, and as of 2K year, we have succeeded in getting a legal agreement delegating all rights to ICM for making nearly complete range of Polish mathematical publications from late 19th century till the year 2K, open access, accessible. As you are here in the context of the programming contest, it is also a Polish mathematical school that has achieved quite special place in global science of 20th century. So we were proud of being able to provide full access to the results achieved by people like Banach, like Sierpiński, like Kuratowski, to everybody. And myself, I was really happy. I got happy when learning in Southeast Asia that a range of monographs by Polish mathematicians became a basic reference source for students. So this was another kind of our activity. Pursuing the concept of openness, we started in '97 another type of activity. We have summer of '97 was a very difficult time for Poland. It was a heavy flooding all over the country. And we learned, well, we just by chance got prepared for, this was considered to be a kind of research effort to make accessible numerical weather forecasts for Poland in a quite high resolution. And so we have decided, as of summer '97, to make this an open access service. It's operational until now. The only difference is that in between, the quality has got quite significantly improved. The resolution went down to quite impressive scale. It is visible as 4 kilometers. It is practically ready as about 1 kilometer grid. which means that we can provide inputs for all, well, on one hand information, on the other hand input for critical management in the crisis situations caused by heavy weather. And this is one of our major contributions to Polish economy and Polish society. Actually, not only Polish, because this is Central Europe, ranging from northern Scandinavia down to Mediterranean. And so the usage is in between quite high, in the mean close to 10 million sessions a month. So the service became quite well known and got its visibility.
Are you forecasting the Europe Cup?
Well, you see, the issue is that in weather forecasting you are limited if you are serious. So, with such a resolution, you can go, say, to 3 days. Otherwise, you have to reduce the resolution. And so, this is an implicit answer to your question. Wait still a moment, then you can learn a proper answer to all questions. We have done this actually in other contexts, namely during the Olympic Games in China. We were asked to cover the sailing contest in Shanghai.
Oh.
So the reason is that we are able to cover the whole northern hemisphere with the system.
Does that service?
Cray. At the time when Cray technology was something extraordinary, especially prior to their, well, how to call it, merging with silicon graphics. But now, when exploring the world of new computer architectures over the last few years, we have identified that to fit into our needs that are really multifold, as I will still shortly address, you need a real technology applicable to quite diverse types of usage. And for us, the most popular cluster technologies were by no means sufficient in many areas of applications of relevance. And this was a motivation for us to go, some years ago, towards a quite original then hybrid architecture, namely that of Roadrunner, composed of x86 on one hand and cell technology on the other. The system that deployed at ICM, manufactured by IBM and fine-tuned in a joint effort, was #1 on the green high-performance computing list for 2 years. As the most efficient, energy-efficient high-performance computing system. In between, we went further to provide access to quite a wide range of technologies. So you have, on one hand, kind of development system based on BlueGene technology for people who need this type of setup. It's a BlueGene P at this moment, and I hope it is not the last character in alphabet that will get located at ICM premises. It is also one of the very first worldwide installations of 775 technology. So it's a Power 7 based high performance computing system, optimized for, on the contrary to Blue Gene, which is massively oriented towards massively parallel applications. The P7 is oriented towards coarse grain parallelism and heavy nodes computing that really is time critical and relies on heavy nodes. So this system has been deployed at ICM last year and provides a composition with, as you can see, both combination of visually oriented modules, massively parallel optimized architectures, and coarse grain.